In this video, I will tell you about the theory of general relativity, the theory of evolution, and the Big Bang theory.
The theory of general relativity was developed by Einstein between 1905 and 1915. According to Einstein, Newton's theory of gravity was flawed. According to Newton's theory, gravity was an instantaneous force caused by the mass of objects. For example, let's imagine the sun suddenly disappeared. According to Newton, our Earth and other planets would immediately veer off their orbits as soon as the sun vanished. There is a distance of 150 million kilometers between the sun and our Earth, and sunlight travels this distance in 8 minutes. According to Einstein, there was a problem here. Nothing in the universe could travel faster than the speed of light. Newton's theory was flawed in this regard. This error led Einstein to provide a different explanation. Einstein added time to the 3 dimensions of space and likened it to a fabric that surrounds us. Massive objects would warp this fabric. He called this space-time. Imagine the sun as a heavy bowling ball placed on a trampoline. The ball would bend the trampoline downward, right? This bending represents the gravitational force we feel. So, according to Einstein, because the sun is a very massive star, it bends space-time significantly, and our Earth and other planets follow this curvature. So, what would happen if the sun suddenly disappeared according to Einstein's theory? The disappearance of the sun would create a gravitational wave in space-time that would reach the planets at the speed of light. This means our Earth would not instantly veer off its orbit. Gravitational waves would travel the 150 million kilometers at the speed of light in 8 minutes. Our Earth would feel the sun's disappearance 8 minutes after it happened. In summary, the theory of general relativity explains that gravity is the result of the curvature of space-time and that nothing can travel faster than the speed of light.
Now, the theory of evolution.
The idea of evolution dates back to ancient times. Even Greek philosophers thought that living beings could change over time. However, modern evolutionary theory was shaped in the 19th century by Charles Darwin and Alfred Russel Wallace. Darwin's voyage on the HMS Beagle in 1831 laid the foundation for the theory of evolution. Darwin observed intriguing similarities and differences among species on the Galapagos Islands. The diversity in finches' beaks, in particular, caught his attention. Each island's finches had beaks adapted to their specific food sources. These observations led Darwin to develop the idea of natural selection. What is natural selection? Natural selection means that organisms best adapted to their environment survive and reproduce. Simply put, it's not the strongest but the most adaptable that survive. Imagine short-necked and long-necked giraffes on the African savanna. Long-necked giraffes have an advantage reaching tree leaves for food. Right? So, over time, short-necked giraffes struggled to survive, while long-necked ones thrived and reproduced. Thus, generations of giraffes ended up with long necks. But how do these changes happen? Enter mutations. Tiny changes in DNA can lead to new traits. Most mutations are harmless, but some provide advantages. Evidence for evolution isn't just genetic. Fossils reveal the history of evolution. For example, the Tiktaalik fossil shows the transition from fish to land animals. It had both fins and primitive legs, illustrating the evolutionary step from aquatic to terrestrial life. So how did humans evolve? It all began about 7 million years ago in Africa with the early hominins. One of our first ancestors, Sahelanthropus chidensis, was among the earliest species capable of standing on 2 feet. Over time, more advanced species like Homo habilis emerged. This species had the ability to make stone tools. Around 1.9 million years ago, Homo erectus appeared. This species could control fire, use complex tools, and spreading from Africa to Asia and Europe. About 300,000 years ago, Homo sapiens, or modern humans, appeared.
And the Big Bang theory. Once upon a time, there was no you, no matter, not even space. Everything was concentrated in a single point, infinitely dense and infinitely energetic. This point was the starting point of our universe. But how do we know this? In the 1920s, astronomer Edwin Hubble discovered that galaxies were moving away from us. The universe was expanding. This meant that if we rewound time, the galaxies moving apart today would converge at a single point. This idea suggested that our universe had a beginning. The Big Bang Theory explains how our universe emerged from this hot and dense beginning. In the first moments of the universe, the temperature and density were so high that the physical laws as we know them did not apply. During this phase, the four fundamental forces of the universe, gravity, electromagnetism, strong nuclear force, and weak nuclear force, acted as one unified force. As the universe began to expand and cool, these forces started to separate from one another. As the forces separated, the universe cooled further and energy levels dropped. During this period, fundamental particles such as quarks and leptons began to form. Quarks are the building blocks of protons and neutrons, while leptons include lighter particles like electrons. As the universe cooled, the Higgs field emerged, and particles interacting with Higgs bosons gained mass. This mechanism allowed fundamental particles to acquire mass. A few microseconds after the Big Bang, quarks combined to form hadrons, protons, and neutrons. These particles became the basic building blocks for the nuclei of atoms in the later stages of the universe. Protons and neutrons combined to form the nuclei of helium and other light elements. This process laid the chemical foundation of the universe and provided the necessary materials for the formation of stars and galaxies. Millions of years later, matter in the universe began to condense to form the first stars and galaxies. These stars illuminated the darkness of the universe and initiated the formation of heavier elements. The merging of stars and the formation of galaxies were significant events that shaped the structure of the universe as we know it today.